Ladies and gentlemen, mutants and monsters, eldritch entities exhausted as I am today. My name is William Baird. I am the head of high performance computing at Guardant Health, and we are a liquid biopsy company. We do cancer detection through blood. Basically, you send us vials of blood, and then we determine whether or not you have cancer or provide, if you have an advanced cancer, what your specific mutations are so you can get proper treatment. Because different cancers, different mutations for the same cancer, all have different responses to treatment. And we are headquartered in Palo Alto, California. We have been there for some time now, over 10 years. But even though we've treated 1 million patients, I have a bit of a headache, and that is with data. We're required to hold my data for 30 years. So whatever I may generate, I've got to hang on to it. I generate now a petabyte of data a week today. We've treated somewhere just north of 1 million patients. Our goal is to get to 5 million patients per year. Linear extrapolation, a dangerous tool, means that we're going to end up doing as much as 700 petabytes a year. And I've got to retain it. This is a problem. And 80% of the data I keep on-prem today is in fact hot. My scientists are training their models, they're doing analysis, they're continuing to improve what we do on all of our historical data. And any data I tend to archive, they tend to pull it back down. And today I have 80 petabytes on-prem. I'm now managing 160 petabytes today. So the way it works today, and has worked, is we move the sequencers right to our production clusters, and we use Starfish to move from our production clusters to our R&D facility, and then that's moved up and archived up in the cloud. This works. It requires some care and feeding, but it is functional. But there was an idea. It was a really stupid idea. In fact, my engineer, who I asked to go try to do it, he said, "Will, this is extremely stupid." He was Russian. And then he came back and said, "But it worked." He was very horrified. We subverted IBM GPFS's HSM capabilities to have multiple file systems point to the same object source simultaneously. This was 4 years ago. And since then, we have worked with IBM and DDN, because they are our on-prem storage provider, to make this a functional product. And IBM's now mainlined it. So in our case, the idea was real basic. Once all of your data is everywhere, anything can be run anywhere. All of your data should look the same wherever you are. It doesn't matter if it's on-prem, a remote cluster, or in the cloud. The scientists are not people who should be digging through and trying to do data management. Where's my data? That's my constant complaint. I need this restored. Also a problem. But we got it to work. The concept is the data is everywhere. Everything, all locales look the same. And it says, in essence, we're using a remote object store and then the POSIX file front end, because our scientists are used to working with POSIX file systems. As I said, the whole concept, everything runs everywhere. The compute locality then becomes a business decision. Do I want to run in the cloud? Do I want to run over here? Do I want to have multiple clusters scattered all over the place that I just launch jobs to based on their availability? And then this allows us to scale in the data sense to an extreme level. It allows me to, because I'm a liquid biopsy company. All I want to do is treat cancer patients. I do not want to build giant HPC centers. It's as simple as that. But at the same time, I still have to have responsibility for this data. But my scientists still want it at all the time. So what can I do? Well, this is our answer. And then it gives us excellent disaster recovery. So we actually did a nuke of a file system intentionally. And then rebuilt it from scratch and reattached it back to the S3 bucket. Well, S3 compatible bucket, I should say. And all the metadata repopulated, and whatever people needed, they were able to pull down. Now, it's like cache and dirty cache, in the sense, if you haven't flushed your cache, you're going to lose what's not there, okay? Just to be honest. So in contrast, you have the single isolated file systems for the most part today. You have data movers such as Starfish or your poison of choice to move things around. In the alternate method that we've ended up doing, you have the single namespace where everything moves around on the back end using AFM. It works pretty well for us. So this is how it would work in a functional manner. Basically, we use Seagate Live Cloud as our back end. There's no ingress or egress fees. This works really well for us, and they've been a great partner for us. We have tied it up to Amazon today. We are working in the process of doing this with GCP. So allow us to, hey, we need to burst. Well, do we want to use Amazon? Do we want to use GCP instead? And this way, all of our local file systems, nothing more than caches. That's all we want to treat them as. We don't want to have them be source of truth. This led to a very, very troubling thought, though. We're now going to be stuck with whatever our partner, in this particular case, IBM, would say the pricing would be, okay? This is very, very important, and it's very, very scary because we take care of cancer patients, okay? Cancer patients, every single thing we incur for a cost has to go to a patient. These people are going through the worst part of their lives, potentially. And, when it comes to we're not going to have much bargaining power when it comes to IBM or any other company we work with, AWS or whatnot, or even Seagate. We're just a small fish in their very, very big pond when it comes to HPC and storage. Well, this led to another stupid idea. What if we asked for help? What if we went to other companies, whether it was Genentech, a rival of ours, Intervent, or the national labs, or so on and so forth, and then also reached out then when they showed interest to the actual OEMs and the integrators and what have you, and said, hey, can we pull your people together to work on this, to make just a standard? Can we have a standard that all these different single namespaces, whether it's IBM, DDN, NetApp, Weka, whomever who wishes to be compliant can join in together? So we built the working group, and there are 34 members. DDN was one of our founding members here. When I first asked, Paul and Alex and all of our people from top to bottom said, yes, we're in. The goal was to produce an interoperability standard. The idea was that we're not going to tell you how to design your software. We want to tell you how your software talk to someone else's, and therefore be able to ingest something you wrote if you decide you no longer want to support something, or vice versa. If the other company no longer wants to support something, you can now connect up and use it. The working group represented vendors and the integrators and the end users. The team worked for well over a year. It first broached when I had the stupid idea in SC23. We went around to talking to all the different vendors and potential collaborators. And then from June 2024 through November 2025, just wrapped up, we had 13 in-person meetings and multiple virtual meetings. And all the presentations and the specifications and requirements are on the GitHub. So please go take a look, because we're now taking it to the next step. We succeeded at this. It covered multiple areas. We had many people, some of the smartest people I've ever met, all contribute. You would be surprised about how many people would argue whatever the definition of something is. What is a backend? What is a front end? What is an orchestrator? What is compliance? And so on and so forth. The very definitions were kind of ridiculous at some points. But then we built a reference architecture, a front end, a back end, described how the interactions should be, the API, and not last on this list, but definitely not the least, was security and compliance. The draft document's in the hands of the tech writers now. It's being mangled, and we will make sure that nothing gets lost in translation as it's been welded together. And the document we will put out on GitHub, so anyone can read this. This is meant to be an open standard. And now we're going to be moving over to Oasis. This is a standards body that will be actually turning it into a public standard. And the call for participation for them should be going out this week. The first technical committee meeting will be in January. DDN was one of our very important participants from the start to finish. They knew people who could help join in, other end users, because we wanted to make sure that when we wrote this, nobody would miss we wouldn't edge someone out and basically say, well, you can't use this with your work kit. We pulled together, there's all sorts of rivals for this, all sorts of people who work together, people who companies who are frankly direct competitors. And it's been a fantastic effort. This has been a meeting of minds that, if you go and look, there was an awful lot of press we put out, whether it was DDN, Weka, Panzura, Polera, a whole bunch of other people all happened to come together and say, hey, we did this, we're proud of it. And that, folks, is what we wanted to talk about. It is actually moving forward. We're very excited. There are some folks, unfortunately, who couldn't get approvals to be up on the, this is who we've done this sort of thing, but it's very much a case of this is something we're going to be doing moving forward. And it does mean if you need to, you can swap what you have when you need to. It means that for me, when I finally do have that 21 exabytes of data, I am not going to be beholden to a company that may raise it up by 100-fold and break the bank.